Right. Good morning again. And in this lesson, we are going to focus on finding the domain of functions. This is often like what I'll sometimes call a bugaboo for a lot of students. They really struggle with the whole concept of what domain is. I have a lot of students that can spit out some kind of definition of domain, but there's a lot of uncertainty in what it is. Now, in the last unit with radicals, we approached domain and range kind of graphically. So I'll go ahead and I'll put like the coordinate grid just to kind of recap what we did in the last unit, where we might have had like some kind of radical function. And we talked about domain is all of the possible x values. And the way I kind of showed it to you was we look at the x-axis and we look at where the graph exists. And so the graph exists, like in this example, from 3 on upward. And so if you like went over to x's 1, 2, 3, 4, 5, you could find a point on the graph, okay, that would have 5 as the x coordinate. Or we could do 6, 7, 8, 9, 10, 11. You could find a point on the graph that had 11 as the x coordinate. And so we would express the domain as x can be any number greater than or equal to 3. You can find the point somewhere. Okay, on the function, like on the graph somewhere, there would be a point that would have that particular x coordinate. And I think that works. And I think it's important because you can see the domain and the range from the graph. And you could do the same thing with your range, doing it with your y coordinates, because you know that the range is all the possible y coordinates. And so this, in this case, we would have like y is greater than or equal to 2. That's one way of approaching it. And one of the things I really like you to come out of Algebra 2 understanding is that the equations and the graphs and the ordered pairs, okay, that you see when you like list the ordered pairs, these are all the same thing. They're just different ways of picturing or representing the same mathematical relationship between an x and a y. You can do it with a bunch of points, you can do it with a graph, or you can do it with an equation. So, but this lesson, we're going to approach domain kind of thinking of it in terms of the equation or the function as opposed to the graph, because what we haven't done is looked at the graphs of a lot of things. And what I'm going to do is give you a rule that is going to work, I'm going to say about 85 to 90% of the time, which is pretty good. Most of you, if you could be guaranteed to get something right 85% of the time, most of you would be okay with that. 90%, that's like an A. You'd be okay with that. So I want to be really clear that this is not a foolproof thing. It is not going to give you the right answer every single time. There are exceptions to this, but it's going to work a lot of the time. And if you really understand how this works, then when you encounter the exceptions, you just kind of need to file the exceptions away like in your brain under like, okay, this is one of the exceptions. And then you just learn that exception. But this general principle is going to work really well for you most of the time. So remember the definition of the domain, okay, is all the possible x values. Okay, we're really not going to talk about range here, so for a function. And when this is first introduced to you, usually you've got like some set of ordered pairs, okay? Like, all right, and somebody would say to you, all right, state the domain, and you would simply go through and you would find the individual x values. So you would say, okay, the domain is 1, -2, and 4. And that's pretty simple, except that most of our functions don't look like that. Like most of the time, we're not looking at like the set brackets with a bunch of ordered pairs. Like we might make a table that has some ordered pairs on it, but we're always, and if you're my student in class, you know that I'm always saying, how many x's could we pick? And the answer is usually infinite. And so there's no way you could list an infinite number of points and an infinite number of x coordinates, nor would you want to. And so we usually express domain more like this. X could be anything greater than or equal to 3. So here's the deal, is that the way I want you to default to domain is I want you to think in terms of what can't X be? Okay, so we're going to kind of turn the thinking around. Okay? We're going to think, what can't X be? Instead of thinking, what could X be? Because X probably could be an infinite number of things. All right, I had kind of a long break in here that you can't tell that I had a long break, but I did. So when it comes to domain, we're going to think in terms like what can't X be? So you've got your number line, okay? This is like your X axis. And you've got all these real numbers on the number line. And we start with X could be any of those numbers. And then we're going to think, okay, is there something that X can't be? Now, there are two main things that will exclude X's, okay? Two main, we'll just use the word thing here, things that will exclude X values, okay? And those two things are fractions and square roots. All right, those are going to be the two main things. There are other things that exclude X values, okay? Tangent functions are going to have some X values excluded. Logarithmic functions are going to have some things excluded. That at this point, you probably haven't heard of either a tangent function or a logarithmic function, so you don't need to worry about them. And even when you do study them, most functions are not going to have those exceptions. But I want to be clear that there are other functions out there. But the two big ones, the ones that are going to cover most just about any exclusion on your domain, or what we call a restriction on the domain, is our fractions and square roots. So I do want to kind of go over a little bit of vocab here. Like because you'll hear this, a restriction on the domain. Okay, so just so we're clear with what we mean by that. Remember that we start with the idea that X could be anything. Okay, any real number. And I'll often ask my classes, okay, what does it mean if your parents put you on restriction? And generally they'll say it means you can't, and then sometimes they'll say you can't do stuff or you can't do specific things. So if you are bad and your parents put you on restriction, they take away certain things that they think that you will enjoy. So you might have a curfew. You can't stay out past, 7 o'clock, or you can't play video games. They don't restrict everything, okay? Like, you are still allowed to come to school. You are still allowed to do your homework. You get to do those things. That you are still allowed, bread and water rations at home. You are still allowed to take a shower and so forth. And so they don't take away everything, but they might take away certain things. And so if your parents were to put you on restriction, maybe if this is when you're allowed outside, maybe you have to be home by 7 p.m. Okay, just kind of putting it on the number line there for illustration. And so they have restricted being outside after 7 p.m. And so you get this idea of a restriction. Or maybe they only take away, I don't know how to do this. Okay. They only take away your phone. Okay. So that's like a common one. And so you've got like everything, and then that phone is taken out. Okay. That's kind of what we're doing here is we're looking at the real numbers and we're looking at what got taken away. Okay. Everything else is still in place, but what can't X be? Okay. And the two things we're going to look for are fractions and square roots. So I'm actually going to, I'll go ahead and write it out. So here, when you're asked for the domain, okay, you are going to train yourself to ask two questions. All right. If you can master these two things, you're pretty much going to be set for domain. Is the function a fraction. And I want to be like specific about what we mean by is the function a fraction. We do not mean that there is a fractional coefficient, okay? We do not mean that x is divided by like some kind of number, because that is really the same as multiplying by the reciprocal, okay? So 1/4 x and x over 4, same thing. So we do not mean, what we mean is this, okay? We mean something like x over x minus 5. Or if you look back into our last lesson with the dividing fractions, that you would have something like x squared minus 2x minus 5 over x plus 2. Okay, that was like one of the ones from the last lesson. So that's what we're referring to. Okay, so you're going to ask yourself, is the function a fraction? All right. Now, the second question you're going to ask yourself is the function a square root? Now, we know that there are other types of roots, but we also know that the most common type of root is a square root. So again, like I said, there's other exceptions to this, but we're going to focus on the most common ones. And again, what we mean by that is not like, do you just see a square root like in it? What we mean is there an x underneath, like the square root? So something like that we saw in the last unit on radicals. Now, here's the good news. We'll change over to red. If the answer to both questions is no, then the domain is likely all real numbers. Okay? Likely. I will go in like box. Likely. Not 100%. There are other I know I'm hammering that point home, but I want to be really clear about it. There are other functions, like other than fractions and square roots, that are going to restrict the domain, but they're not that common. Okay, so if you are looking at something and it says, all right, is the function a fraction? You say, nope. Is the function a square root? Nope. Probably the answer is all real numbers. And if you're taking a multiple choice test, that's what I want you to bubble in. That's likely the case. It means the two big things, okay, that you would get restricted because of, like, they're not there. Okay, so probably there are no restrictions. Now we just have to deal with what if you answer yes. Okay, so here's the thought process, okay? So if there is a fraction, here's the reasoning. And remember, the reasoning is what's important, because the reasoning is what stops you from memorizing random facts that don't have any connection to anything, because you will absolutely forget random facts. Like, there has to be a grounding for why this works, because then you'll remember it, okay? If there is a fraction, here's the important fact you need to remember, is we can't divide by 0. I'm pausing to give you a chance to write it down and to let you think through that. We can't divide by 0. If you grab your calculator, okay, and you do something like 4 divided by 0, I'll like do it on my cell phone calculator. Put my cell phone to the side here, and I'll clear that out. 4 divided by 0, okay, my cell phone calculator turns all red, and it tells me in big red letters, can't divide by 0. Okay, so we cannot divide something by 0. It's an undefined operation. You can't take something and put it into 0 groups and then ask yourself how many are in each group, because there aren't any groups. It's totally nonsensical. Okay, you cannot divide by 0. Therefore, the denominator of the fraction cannot be equal to 0. That is the absolute key. Okay, the denominator of the fraction cannot be equal to 0. Once you've got that, you've got your domain. So here's an example, so you can see how this works. If your function looks like this, and you have x minus 3 over x plus 4, and you ask yourself the question, is the function a fraction? Yes. Okay, x minus 3 over x plus 4, that's a fraction. So now you think to yourself, all right, we can't divide by 0. Therefore, the denominator cannot be equal to 0. And here's what you do. We're going to say the denominator cannot be equal to 0. What is the denominator? The denominator is x plus 4. And now I know that says does not equal, but we're going to treat it like an equation, and we're going to subtract 4 from both sides, and we're going to say x does not equal negative 4. That, my friends, is your domain. X does not equal negative 4. So if you were to go back to our number line, okay, and you've got all those beautiful numbers on it, and it's like all the real numbers, and it was so pretty, and we loved it so much, X can be all of those numbers except for the negative 4. It's like your parents just took away your cell phone. No curfew, no video game restriction, no TV restriction, no Netflix, like nothing like that, but you can't have your phone. Okay, they only took away one thing. And so it's a lot easier to think like in terms of what can't X be. So let's go back to our problems from last class. All right, these are problems. So if you flip back in your notes, which hopefully you have some notes. So problems from last class, where you would be asked, like, what is the domain? So one of them was, it was f over g of x, and we had x squared minus 2x minus 5 over x plus 2. And so if you were asked, like, what is the domain? Then you say, okay, is my function a fraction? So you're going to train yourself to ask, like, is it a fraction? Why, yes. Yes, it is. The denominator cannot be equal to 0. In this case, the denominator is x plus 2. So we go and we subtract true, and we get x does not equal negative 2. And there is your domain. Hopefully not difficult, okay? Because if you were to plug in a negative 2, you would have negative 2 plus 2, which is 0, and you can't divide by 0. Like, can't do it. Like, that's undefined. The other problem was g over f, and that one was x plus 2 over x squared minus 2x minus 15. Now, you'd ask yourself the question, is the function a fraction? Yes. Yes, it is. Now, this one is trickier, but math is good. Math is consistent. Like, the rules for math don't change. Okay? And so once you get the reasoning, that's why the reasoning is so important, and you're not just trying to memorize, oh, I flipped the sign on the number, and like, no. Like, the denominator cannot be equal to 0. That concept is not ever going to fail you. Okay, little tricks and shortcuts will fail you, but the concept won't. Can't divide by 0 because it's not defined. So x squared minus 2x minus 15 cannot equal 0. That's a quadratic. And if we're going to solve it, we have to factor it. So we're looking for two numbers that multiply to negative 15 that add up to negative 2. That's going to be a negative 5 and a positive 3. Just like it was an equation, except instead of equals 0, we have does not equal 0. So we have two things that can't equal 0. So we're like applying the zero product property in this kind of messed up way. Add 5 to both sides, so x cannot equal 5. Over here, subtract 3 from both sides, and now you actually have two different things that x can't equal. So the domain is x does not equal 5, comma, negative 3. I swear, if you give me that answer in interval notation and you can't explain what it is, like, you definitely don't want to answer this in interval notation. So the concept is the same. Now, hopefully you're getting the concept here. But now you might say, well, I don't remember the factoring, or I wouldn't have thought of factoring. Well, I've just demonstrated it for you, so hopefully, like, you can kind of reason your way through that now that you've seen it done out once. But remember, it's the concept, okay? Denominator can't equal 0. So last class, there were two practice problems, and you should have come up with, what should you have come up with? 2x minus 1 over x squared plus 3x minus 28. And then the other one was x squared plus 3x minus 28 over 2x minus 1. And I would like you to find the domain for these. And again, you're going to tell me what x isn't. Okay, and hopefully this is what you came up with. If we're doing this in class, probably we went over it together. But for the first one, you should have, denominator does not equal to 0. And so you have the quadratic down there. You have to factor the quadratic, apply the zero product property, and you should have ended up with x does not equal negative 7 and 4. Okay, so it's like your parents took two things away from you. They took away your cell phone, and they also took away your hairdryer. Okay, I don't know. Whatever works, okay? Or you could avoid getting put on restriction altogether. So that's probably a better plan. For the second one, you've got, you should have ended up with x does not equal 1/2, okay? Because if you plug in 1/2 into the denominator, 2 times 1/2 is 1, and 1 minus 1 is 0. Now, something I do want you to notice about this is that the problems do vary in difficulty levels. So as you get more experience at doing the problems, you're going to recognize the easier ones from the harder ones. And you always want to kind of home in on those easier ones first. You want to demonstrate everything you do understand, and then kind of work your way back to the ones that are harder. And if you are struggling with the harder ones, note where you're having the problem, because the problem might be that it's the factoring, which is not a domain issue. That's not an issue with understanding the algebra, the functions, or the domain. That's an issue with factoring. So you want to kind of home in on exactly what causes the problem for you, particularly if it's not the overall concept. Now, I told you that there are two questions you're going to ask yourself. So we've dealt with, is the function a fraction? What happens if you answer yes to the second one? Okay, so you say, yes, there is a square root. Be consistent with how I'm doing this. So if there is a square root. Now, one of your options is to graph it. That's what we did in the last class, was we looked at the graph of the square root, and you're able to see the domain off the graph. And that works too. And what you get from the algebra should match what you get from the graph. They should be the same answer if you have the same function. So here's the reasoning here. The square root of a negative is imaginary. And I loved what happened in class last week when we did this. And I think it was in period 6. One of the students said, I said, what do you get? You take the square root of -4, -2, and the student blurted out, imaginary something. I was like, that's perfect. Imaginary something. You don't even need to know what it is. It doesn't matter if it's 2i or 3i. If it's an imaginary number, you can't graph it. It's not going to be on the graph anywhere. Therefore, what we know is that this, whatever, I don't want to say positive though, this must be greater than or equal to 0. Okay? Just to be clear, the square root of 0 is 0. That's totally okay. Okay? The square root of a positive, it could be yucky, but it's okay. The square root of a negative is imaginary. Okay, so the problem is not if it's 0. So it can be equal to 0. So whatever is under the square root has to be greater than or equal to 0. Okay, that's the reasoning. That's what's going to help you remember this. Okay, I don't want you memorizing random facts here. So what you're going to do, we'll look at this. If you have f of x is equal to the square root of 3x plus 4, okay, here's your reasoning. Under the square root has to be greater than or equal to 0. You look at whatever is under the square root. 3x plus 4 has to be greater than or equal to 0. And then you're just going to go ahead and solve it. So you subtract 4 from both sides and divide both sides by 3. And x is greater than or equal to -4/3. Ta-da! Whoops. Okay. I slid that funny. Okay, and there's your domain. Now, just to connect this, okay, because connecting is important. I probably should go back to that last page and let you think about that for a moment. I'm watching the clock here. I'm like, oh, we gotta get done. Okay, so just to connect the ideas, suppose you had this graph. You had like the square root of x minus 4 plus 5. And you know that this goes right 4 and up 5. And so you go 1, 2, 3, 4, 1, 2, 3, 4, 5, and you graph it. And you do this the way that we were doing it last class, which is you kind of look and see where you are on that x-axis. And so you come up with the domain is x is greater than or equal to 4. Okay, so you can get it off the graph. Now let's just do the same thing using this process. So you say, yes, there is a square root. And you kind of think through it this way. Under the square root has to be greater than or equal to 0. Well, what's under the square root? X minus 4. Add 4 to both sides. X is greater than or equal to 4. Ta-da! I know you're probably not as impressed by this as I am. Okay? But what you get from the equation, doing it like with the thought process with the equation, should be the same thing you get by graphing and looking at it. Like they should be the same answers because they are the same thing. They're the same problem. You're just demonstrating or illustrating the same concept in different ways. And what we're saying is like, this is kind of like having that curfew where you have to be home at 7, okay? And anything, whatever, like here you can be out. Okay, like basically on the number line, it's going the wrong way. But you get the idea. And I want you to be able to make those connections because a good math student is able to draw on whatever works best for them. So I'm going to give you some practice problems to just kind of practice finding the domain. I think I'm going to change them up from what's in the notes. So give me a second. I'm going to write these out and you are going to find the domain. Okay, we've got some fantastic problems here. So I want you to find the domain of f of x is equal to 3x minus 4 over x plus blah, 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 minus 5. F of x is equal to the square root of x minus 6. F of x is equal to cosine of x plus 2. Like what is that about? F of x is equal to 2x squared minus 3x plus 1. And f of x is equal to negative 2x plus 1 under the square root minus 3 outside the square root. So we will stop the video at this point. And for those of you watching at home, I will take you through the answers to this in the last 2.5 minutes of video time that we have. Okay, so for those of you still with me, we ask ourselves 2 questions. Is it a fraction? Is it a square root? For the first one, we say, is it a fraction? And the answer is yes. So we say to ourselves, okay, the denominator cannot be equal to 0 because you can't divide by 0. X minus 5 is the denominator, and we add 5 to both sides, so we get x does not equal 5. X can be anything except 5. Okay, there's the first one. Second one, you ask yourself, is there a fraction? Nope. Is there a square root? Yes. And the key with that is under the square root has to be greater than or equal to 0, which in this case is x minus 6. Add 6 to both sides, and x is greater than or equal to 6. Ta-da! There you go. There's the second one. Third one, totally messing with like everybody there. Okay, but remember, I said there are exceptions, but I said they're not common. So you ask yourself, is that a fraction? Nope. Is it a square root? Nope. So if you have to guess, you are guessing all real numbers, my friend, and you would get it right, even though you probably have no idea what cosine of x plus 2 is or what it looks like. Fourth one, is it a fraction? Nope. Is it a square root? Nope. It would be all real numbers. And if you remember back to our unit on quadratics, I said the domain of every quadratic is all real numbers, and now you know why. Last one that we have there. This one might throw you off a little bit. People say, well, what about the minus 3? The minus 3 is going to bring the graph down 3 on the coordinate plane, but it doesn't slide it left or right. So because it doesn't move it on the x-axis, it doesn't change the domain. Under the square root has to be greater than or equal to 0. Negative 2x plus 1 greater than or equal to 0. Subtract 1. Divide by the negative. You're going to have to flip it around. and you will get the domain is less than or equal to 1/2. And that's because that negative will flip it over the y-axis, and I'm out of time.